In this video, we'll take up the homework on modeling periodic behavior. So the first question is asking us whether the following graphs are periodic. If they are periodic, try to determine the period of the function. So for 1a, it is a periodic function and the period is 5. For 1b, it's definitely not periodic. You have a quadratic function. For 1c, you actually have a very special graph. You have the graph of the tan function. And the tan function has a period of, in grade 12 you're going to say it's that the period is pi. In grade 11 you say the period is 180 degrees. But anyways, if you look at the picture, it's you can approximate the period to be about 3.14, which is pi. For question 2, you can draw the graph of any periodic function as long as the properties are fulfilled. So you need a max value of 11, a min value of 3, and a period of 4. Okay, so hopefully your graph is a little prettier than mine, but you know, it gets the job done. So what's the value of this function x equals 1? Well, for my graph, when x is 1, the output is 3. And for c, determine the other values of x, 2 other values, so any 2. So all you have to do is add by the period and you'll get your other answers. So when x is 5, when x is 9, and the next one, 9 plus 4 is 13. So at 13, you also have a y value of 3. It just keeps going on and on and on. That's the beauty of periodic behavior. It's very predictable. All right, so for 3, because the period is, so the period is 8, because the horizontal distance between 1 and 25 is 24. So if you have 3 periods is a horizontal length of 24, then proportionally speaking, 1 period has a horizontal length of 8. All right, perfect. For question 4, is trying to look for the distance of the luggage here. So it reaches a maximum distance of 8, and I guess you can say the luggage is right beside you. So the minimum distance is 0 and the maximum distance is 8 meters, because the radius is 4 meters and the period is 45 seconds. So that's why that this graph repeats itself after every 45 seconds. So the 45 seconds represents the period. The 4 meter represents the amplitude, and then closest is 0, and furthest is 8. And yeah, and it's definitely periodic because this motion of this luggage carousel is repeating itself after every 45 seconds. For 5a, it asks us to construct a graph that models the distance from the first bench as a function of the time in seconds for 3 cycles. So I looked at the answer key and I didn't think I could do a better job than what was already there. So you can refer to the answers and you'll see a beautiful graph that represents the periodic nature of Rosie's movement. For 5b, it says how many cycles can she complete in an hour? Since the period is 1 minute, that means in 1 hour, you will, if you were to graph it, you'll see 60 cycles. And if it's an 8-hour daily shift, then we're looking at 480 cycles. And in 200 days a year, we're looking at 96,000 cycles. And lastly, over 35 years, that's 3.36 million cycles. So once again, the beauty of periodic behavior is that it makes everything very predictable. So hopefully